Alright, so let's kind of review what we've gone over with trig that we did before spring break. Remember the test you took, we did have 2 bonus questions that utilized this trigonometry that we were learning, but we haven't actually practiced it as an actual assignment. So I thought it was the perfect way to kind of kick off this e-learning that we're doing. So we made this trigonometry flip book. Again, it's okay if you don't have that home. Everything is going to be right here for you. So we made our trig book that had sine, cosine, and tangent. We had some mixed practice of having to understand under what circumstances did we use which trig ratio. And then we had some applications with angle of depression and angle of elevation. So we'll go over those again. Alright, so when we were making this, we also talked about the use of our calculator. And when we were using our calculator, the trig button was right there next to the number 7. And whenever you press number 7, or the trig button next to number 7, you get the option of all of your trig ratios. Remember, we're looking at sine, cosine, and tangent, and then also their inverses. We talked about how another way of saying inverse is arc. So inverse of sine or sine inverse can also be called arc sine. The reason for that is that -1 is just the notation for saying that we're doing the inverse of sine. It's not an exponent. So we talked about how you cannot treat it like you did in Algebra 1, where if you had a negative exponent, you bring it to the bottom. That's not how this works, okay? Then we also talked about in your calculator, you need to make sure that your calculator is in the degree setting. Otherwise, you're going to get different answers. So in that screenshot of my calculator, I had it in radians, RAD. So I have the list here of the steps you can take to make sure it's in degrees. When you're on your home screen, you press number 5 to go to your settings. Then you do the document settings. And that second option right there, or the second feature, is the angle. And you want to change that to degree. And then if you say make default, that allows your calculator to just always be in degree mode, so you don't have to change it each time. Now, the first ratio we discussed was sine. And sine is opposite over hypotenuse. That's what the SO from SOHCAHTOA is. SOH, sine opposite hypotenuse. So we went through and identified what the sine of an angle is. So as you can see, depending on if we were talking about angle A or angle B, sine, opposite, and hypotenuse, the opposite leg is different in each of those scenarios. The hypotenuse is always the hypotenuse. It's always the part of the triangle that's across from the 90-degree angle symbol. It's also the longest side of the triangle. So then we went through a couple of examples of using sine to find a side length and also an angle measure. So for number 5 here, finding x, so we're looking for the opposite leg. Remember, we identified the pieces of the triangle that we have, opposite and hypotenuse. So sine of the angle, sine of 41, is equal to the opposite leg, x, divided by 17. So to get x by itself, we had to multiply by 17 on both sides, and then we use your calculator to get the decimal approximation. Then for finding angles, this is when we introduce the inverse. So number 3 here, sine of angle x is equal to opposite is 9, hypotenuse is 14. Well, to get x by itself, we need to do the inverse of sine. It's just like when you're multiplying, the inverse of that is division. Or when you're adding, the inverse of that is subtraction. So the inverse of sine is sine inverse. And what we do to one side, we do to the other. So that then cancels out the sine. So we have x equals sine inverse of 9 over 14. And then again, use your calculator. So that was for sine. Then we went to cosine. So cosine was adjacent over hypotenuse. The adjacent leg divided by the hypotenuse. So that's a different part of the triangle than we had for sine. So number 11 here, solving for x, that's the adjacent leg to angle 62. So cosine of angle 62 equals x divided by 7. So to get x by itself, we need to multiply by 7. So then we get our decimal approximation. Now we also talked about how this is related to using sine. The leg that is identified as x is actually opposite of that angle 28. Remember, all three angles in a triangle add to 180 degrees. So we just took 180, subtracted 90, and subtracted 62 to get 28. So if we were to use sine of 28, it'd be x over 7. So we'd multiply by 7 again. And look, we're getting the exact same decimal value as we did with cosine. So it goes to show you that the length that you're looking for is going to be the same value no matter which one you use. It all depends on what information you're working with. Now let's look at number 12, just because it's slightly different than number 11. In this case, the hypotenuse is the x. So cosine of 24, the adjacent leg is 27, divided by x. Now x is in the denominator. Remember, the first thing that you're going to do is multiply both sides by x, so that we have x out of the denominator. Now what we need to do is divide by this cosine. So that's how we get x is 27 over cosine of 24 degrees. Now to find an angle, we can look at number 9. So cosine of the angle, cosine of x, is equal to 44 over 52. That's adjacent over hypotenuse. To get rid of the cosine, we had to do the inverse of cosine. So x is cosine inverse of 44 over 52. Again, go to your calculator to get the decimal. Now the last ratio was tangent. Tangent does not utilize the hypotenuse. It uses the opposite leg and the adjacent leg. So now we just need those two sides of the triangle. So here's number 11. We have angle 75 degrees. X is opposite of that angle, and 18 is adjacent to it. So tangent of 75 is equal to x over 18. So multiply both sides by 18 and get your decimal. Number 18, we have an angle of 39 degrees. The opposite leg is 49 and the adjacent is x. Again, another situation where you have x in the denominator. So you multiply by x first to get x out of the denominator, and then we need to divide by tangent of 39 to get x by itself. Now, just like before with finding the angle, that's where we're using the inverse trig features. So tangent of x is equal to 21 over 25. So we have to use inverse tangent in order to get x by itself. So x is equal to the inverse tangent of 21 over 25. So those were our 3 trig ratios. And remember, there's an easy way to remember which is which. So, toa. So, sine is opposite over hypotenuse, right? S, O, and the H. Is cosine is adjacent over hypotenuse, C, A, H. And then toa is tangent is equal to opposite over adjacent, T, O, A. So that's how SOHCAHTOA can help you to remember which is which. Alright, so the last piece were those application problems where we talked about angle of elevation and angle of depression. So, angle of elevation. Elevation means something's going up. It's like I'm on the ground and I'm looking up to the top of the building. So the angle of elevation would be this angle here at the ground. Remember, theta is kind of our representation of an angle. Depression is going down. This is like being in an airplane and looking down towards something. So depression is going to be the angle here up top.